This is a fun project I started a while back. My goal was to play internet streaming program content to the vintage radios shown there in the background. In fact, I wanted to play the actual vintage or old-time radio programs themselves, the comedies and dramas on the actual radios from the era of the program. So for instance, a 1940s radio program like the Long Ranger would play on a 1940s era vacuum tube radio. Yeah, it's a little gimmicky because you can listen to the program on modern equipment, but I thought it'd be a fun project to use the radios I picked up at a garage sale. The problem is that there's no way to connect these old radios to Wi-Fi or even input audio to them from a streaming internet-connected iOS or Android device. So I came across the Ramsey AM radio transmitter kit, the AM25, which would wirelessly stream internet content from, say, the iPod Touch or any mobile device. The audio from the mobile device would be applied to the AM transmitter audio input, which would then use the analog modulation technique required for AM broadcasting, and the resulting RF signal would be picked up wirelessly and played on the vintage radios. A cable from DigiKey, part number CP-354S-ND, also shown there, would connect the mobile device audio to the Ramsey AM25 transmitter audio input. So these are the radios I picked up at the garage sale. This is a cool Art Deco model. It's called the Bendix Aviation from the Bendix Corporation. I checked on the internet and they were manufactured between 1945 and the late 1940s. So this would be a kind of radio that would be purchased by, say, a GI or a family, young family after World War II to listen to the content that was popular in the 40s and 50s. I guess the 40s was a little dated for Art Deco, but it looks kind of cool. Oh, this radio is a Westinghouse broadcaster. I wasn't able to find it on the internet, but it's the font on the radio face is sort of a modern era 1950s Mad Men type era. So I probably 1950s for the Westinghouse. It's got 4 knobs on it. The Bendix only had 2 knobs. This has an additional knob called tone, and it actually has a knob called radio or phono. So I think you could put your phonograph record audio input to this thing, but I wouldn't try to do that. It uses vacuum tubes with high voltages. It's kind of dangerous. So I don't think the audio output from an iPhone or something would be enough for this radio to use the phono input. But it does have 4 knobs, which is a great feature. They all have about 5 vacuum tubes in it, so they glow pretty brightly. I wouldn't use this on a regular basis. It'd probably be a huge energy hog. But if you live in a cold climate, they serve as a space heater. So you can turn your heater down when you listen to your 5-tube radios. So this is the Westinghouse broadcaster. And here's the back end of the Westinghouse, and you can see the tubes glowing brightly. So dangerous, I don't even get too close. It's probably real high voltage in there. And back over here to the Bendix, you can see some kind of lights going on in there. Again, you don't want to use these on a regular basis because I'm sure they're burning up a lot of power, but they're kind of cool. And you can kind of hear the noise going on. So this is the business end of my vintage radios. Okay, so we're at the workbench now, and we see the completed AM transmitter kit. I'm guessing that it took me about 20 hours to complete it, to install all the parts and check it out. I did it during baseball games. Baseball is sort of well suited to assembling kits. It's kind of a slow-paced game. but I'm estimating about 20 hours to complete it. I would, in my personal opinion, I would say this is an intermediate level complexity. I don't think a beginner would have a very easy time with this, but it's not an advanced kit in that there's no surface mount parts. All the parts are big and dual inline or axial or radial parts, and they're pretty easy to handle. A beginner might have a little trouble, although the instructions are complete. They're kind of missing a lot of diagrams and pictures that would be helpful to a beginner. So in my opinion, it would be an intermediate level kit. It doesn't come with a power supply, so maybe you can see that power cube I have. It's a 12 volt, it requires 12 volts DC at a 250 mils. I found a 500 milliamp power cube with a connector that just fit right in there. You're going to need some RCA connectors from Radio Shack as well on the antenna, which you can maybe see on the upper left. I'll get a close-up a little later on. And the audio input using that DigiKey cable from the iPod or iPad to the radio itself, where you provide the modulation audio. So I'll take a closer look at the kit. Here's a close-up of the transmitter. You can see coils in the upper left-hand corner. That adds a little bit to the difficulty of the kit. So you have to wind each of those coils individually. You have to keep count of the number of turns, and that would again put it in the intermediate level for complexity on kit assembly. There are no sockets provided for the ICs. I soldered them directly to the board, but a beginner may want to include or purchase their own dual inline sockets for the ICs, so you don't have to apply heat directly to the device. But other than the coils and a few RF things, it's very straightforward and not too complicated at all. Okay, the transmitter kit uses a synthesizer to come up with the operating frequency. So the procedure is to find a clear spot on the AM dial, and be sure you listen at night, because distant signals come in at night and interfere with your signal. So I selected 570 kilohertz, 570 kilohertz as my operating frequency. So I'll show you how to set up the dip switch on the synthesizer, which sets the RF transmit frequency. So first of all, you enter 570 as the frequency on the calculator, and the instructions say the first thing you do is divide by 10. So 10 divide, and there's 570. So then we convert 57 decimal into the binary equivalent, and so that's that, and we select the base, and we select binary, and we see that the result for 570 kilohertz on the synthesizer dip switch is reading from left to right 111001. So we write that down on a piece of paper, and we set it in the dip switch as I'll show you in a bit. Okay, here's a close-up of the dip switch, and we calculated 570 kilohertz to be a binary equivalent of 111001. Now you can see on the dip switch that number is set in there. It's kind of encoded. So a 1 is a depressed switch. So we have 1, 2, 3, 4 depressed switches. So those are the 4 ones. So reading from left to right again, and this is 8 bits, and our calculation only came up with 6. So we put in zeros. We zero fill the most significant bits. So starting from left to right, we have 0, 0, and then we have our 3 ones, 1, 1, 1, and then we see the next 2 switches are up, which are zeros, so it's 0, 0, and the last switch is down for the final 1. So it's reading from left to right, 0, 0, 1, 1, 1, 0, 0, 1 in binary, which is 570 kilohertz for our ultimate transmit frequency. Okay, so we have our radio hooked up to a power source, and the power source is plugged into the AC outlet, and we're ready to go on the air and try out our transmitter. Now we have the test radio on, as you can probably hear. It's pretty loud, and I've set that for 570 kilohertz, which should be our operating frequency. So we turn on the power with the power switch, and immediately the radio goes silent as it's picking up the carrier wave of the transmitter. It's unmodulated right now. We don't have our audio source hooked up, so it's just going to be an unmodulated carrier wave, which reduces the noise. You can maybe see the light. There's a LED that's on in the lower right-hand corner, if you can see that. But that is a little tricky because that's not a power switch. That's connected to the phase lock loop in the synthesizer. So when that light is on, it means that your transmit frequency is phase locked to the crystal standard, and you can be confident that it's at the correct operating frequency that you set in, and at the dip switch. To our left, we have a piece of wire as the transmitter. The rules in the book say that can't be larger than 6 feet as an antenna, and I've got about 5.5 feet of wire as the antenna. And we look up on the oscilloscope, and we can see that the signal is being output, and I've got the approximate frequency up there. If you can read it, it's 0.570 megahertz or 570 kilohertz. So let's hook up the audio now and see if we can get the modulation to work. Well, we've hooked up the audio to the iPad. It's a little easier to see the programs running on the iPad than the iPod Touch. So we'll demonstrate using the iPad. And we can see that the power is applied to the transmitter. We can see the red LED for phase lock loop. So everything's looking good. Let's go ahead and apply the audio by hitting the on switch on the iPad. And we hear the tone. We can change the frequency. And let's look on the oscilloscope. And we can see the lower frequency modulating the higher frequency radio carrier. And it doesn't appear to be clipping or anything. With a sine wave, I'll turn that off, it's a little tedious. With the sine wave, we want to set it so it doesn't distort, but a normal speech has a higher peak to average ratio than the sine waves, so we want to set the modulation to be much less than 100% with a sine wave, so that when we put speech on there with a higher peak to average ratio, it still won't clip. So let's tune into a radio station and see if that works. Okay, here's the iPad, and the application that we're going to demonstrate is called Yesterday. Yesterday, it's available in the App Store. And I'll fire it up here. And the great thing about Yesterday is it allows you to enter your own URLs. So I've programmed in a couple of URLs from the vintage radio programs, the old-time radio stations that will play on our vintage radios that showed earlier in the video. So let's just fire up a couple and make sure that they're working here in the test radio. So let's do old-time radio.
You will bring the $50,000. Everything. Mr. Jackson is everything like that. Hurry. We'll be waiting for you.
Okay, that's some kind of mystery. Let's go back to AM1710.
Come in.
Hello, Mrs. McGee. Hello, Mr. McGee. Welcome home.
Oh, Mr. Wimple.
Hi, Wimp, old man. How you feeling?
Oh, not bad, Mr. McGee. Except I'm a little sore up here.
Oh. Did you break
Okay,
your
that's,
collarbone or something, Mr. Wimple?
Oh, no.
That's-
I just went and got tattooed.
Tattooed.
Oh, my gosh, a rabbit. What'd you get a rabbit tattooed on there for, Wimp?
I thought Face would like it.
Oh.
She often said she wished I had a little hair on my chest.
Okay, I don't know what that's all about. But you can see that the old-time vintage programs are working through the transmitter, and we'll go ahead and try them with the radios next.
Starring Bill Johnstone as Lieutenant Ben Guthrie and Wally Mayer as Sergeant Matt Grebb, the lineup comes to you through the worldwide facilities of the United States Armed Forces Radio Service.
Now, Autolite and its 60,000 dealers and service stations present Suspense.
Tonight, Autolite brings you Ronald Coleman in Noose of Coincidence, a suspense play produced and directed by Anton M. Leader.
If you're a fellow who won't put up with second best, what are you waiting for? Replace those old narrow gap spark plugs with wide gap Autolite resistor spark plugs and see the difference in your car. Your car will idle smoother, give you better power and performance on leaner gas mixtures, actually save gas. Autolite regular type spark plugs have long been standard factory equipment on many leading makes of cars and trucks. And now six of these leading makes of cars and trucks have switched to Autolite resistor type spark plugs for factory installation on their new 1949 models. The new wide gap Autolite resistor spark plugs are the spark plugs of today and the future. Remember, you're right with Autolite.
And now, Autolite presents Ronald Coleman in a tale well calculated to keep you in suspense.